Good afternoon, DEF CON. Got a great talk for you today. Christoph and Matt are going to talk to you about weaponizing trust. Please give a nice DEF CON welcome to Christoph and Matt.
Hi everyone, thanks for coming to our TED Talk, to our DEF CON talk. So this is our first time speaking at DEF CON, and we're very excited. Matt is coming all the way from Scotland. I'm coming all the way from Switzerland, so thanks for being here. This is the story of us investigating a threat actor that we called the MUD 1244 that started in December 2024. At first, we thought that the investigation would look something like this, going nicely from point A to point B in a very linear fashion. In the end, it went more something like that, where we had a few hiccups along the way, some discoveries that we didn't really understand at the time. And I just want to acknowledge that many of the talks we see today at Black Hat, at DEF CON, they might look like this, but most of them are actually like that. So if you are working on a project and things look like that, you're probably doing the right thing. My name is Christoph. I work at Datadog. I focus on cloud security and open source topics and get to do some threat research when there's a chance. And this is Matt, my partner in crime.
Hi everyone, my name's Matt. I'm a security researcher at Datadog as well, mainly focusing in malware analysis and threat research.
Great. So again, this story starts in December 2024 with a blog post that we read from Yehuda Gelb at Checkmarks that was talking about a malicious NPM package called OXEngine XML RPC. Now, this package is very similar to the one you see on the left, which is a legitimate one called XML RPC. The malicious one has the same README, same functionality, very close code, except that it has a backdoor in it. So if you open the code, you'll see this extraneous validator.js file that contains obfuscated code. Now, if you just take a bit of time and you rename it, you deobfuscate it, you get something like that, which is basically adding a bunch of files to a zip file and then uploading that to an attacker-controlled Dropbox account. Now, if you wonder how the authentication is working, you might have guessed it, hard-coded credentials, right? And so this is the client ID, client secret, and refresh token that allow anyone to get an access token for the Dropbox API. Now, if you were to do that, you would see that the scope of this access token doesn't only allow uploading, but also reading the files in this account and getting metadata about the Dropbox account. This is the endpoint in the Dropbox API that allows you to query metadata about the account. And for us, it's useful because we want to know, who this account belongs to and what they are doing with that. So you'll see here that the email attached to this account is Paul Muir 1977. Keep that in mind because it's a username we're going to see a few more times in this talk. If you keep going and look at the Dropbox API docs, there are some endpoints to list the folders, list the files, of course. So what we have in there is a bunch of zip files, and we know what the name looks like because we can see the code that uploads it, right? So the first part is the compromised machine ID, and the second part is the timestamp at which it has been compromised. So what do? Unpacking time, right? We have a bunch of zip files, and we want to figure out what's in them. So there are two files in every of these zips, si.json, which is system information, and targets.txt, which seem to contain some credentials. And these credentials have URL, username, and password. Now, there are actually quite a lot of these credentials, namely a little bit less than 400,000. So it was an interesting discovery. But at the time, I was very confused. I looked at Matt. I looked at Matt over Zoom because it's 2025, and I told him, hey, Matt, this is weird. This is not your classic info stealer, right? Because you don't have end users that have thousands of credentials for thousands of domains on their laptops. So at this time, we didn't fully grasp what this was or where it was coming from, and we'll get to that later. But we know that the structure of our attacks looks something like that, right? We have, very simple for now, malicious NPM package, exfiltrating data to an attacker-controlled Dropbox account. If we keep going and look at the code, we see that there is another piece of the code that downloads the second stage payload from this URL, codeberg.org XMR dropper. And what this is doing is essentially first dropping a coin miner, you guessed it, but also dropping an info stealer, a very simple one written in Bash that looks at your AWS folder, Azure folder, Electrum folder, Bash history, SSH keys, and then sends that, as you can see at the bottom, to file.io, which is a file sharing service. So now we have this structure, right? We have a second stage uploading data to a Dropbox account, and a second one that uploads data to file.io. Now, the attacker was kind enough to make that repository publicly available on Codeberg. So it's nice for us because we can see the commit history, the commit metadata, the different updates that they do to all the different payload files. But more than that, they also make available a second repository called spam, which contains a few things. So if we have some people working in academia here, PhD students, professors, postdoctoral students, you know that every time you write research papers, your email is basically out in the wild, which makes it quite easy to scrape. And this is what this attacker is doing. So in the repository, we have a file called emails.db that contains a few thousand of emails that the attacker scraped off Arxiv, which is a papers sharing website for researchers. Next to this file, we can see the headers of the email phishing campaign that this attacker uses. So we have the recipient test email, which is Paul Muir 19777, very close to the one we had for the Dropbox account, right? And we have a subject of a phishing campaign. You have to update your microcode, CPU, whatever. That's the body of the phishing campaign. That looks somewhat legitimate. I would probably click on that. And it's telling you how you need to update your microcode for your CPU, whatever. And you have to click this link, opencompiled.org/microcode-patch-linux, which brings you to this page. Now, it looks like it was designed in the 90s, but I think it looks somewhat legitimate. You have this changelog from the Linux kernel, and you have to use this command to update your kernel. That's a click fix campaign. It's called a click fix type of attack. It sounds very dumb, but we see quite a lot of them in the past few months or so, and it works very well for non-technical users. If you were to run that, you end up with a script that comes from GitHub, and the interesting thing here is that this thing ends up dropping the same second stage payload as before. So if we take a step back, we had that before, and now we found a second initial access vector, a phishing campaign, that ends up dropping the same second stage payload. Now, at this time, there was, again, a bit of confusion because we weren't that sure why would anyone use this NPM package. Like, why would anyone install that or run that, right? It seems very boring, super uninteresting, so why would anyone do that? And anything else, Matt, that you want to add on that?
Yeah, sure. So we performed an analysis of the XML RPC NPM package and discovered that the exfiltration target was a single hard-coded file named targets.txt. Now, obviously, this is highly specific. So first of all, we wondered how exactly did this file end up on the file system in the first place? And since the malware within the package itself expected it to be present, we also assumed that there must be some other attacker-controlled process that we hadn't yet seen. So we continued pivoting on some of the artifacts that we'd found up until this point, and we discovered a Bitbucket repository for a tool named Yop, and you can see an example of the homepage on screen here. Now, the README for this tool claimed that it was supposed to be used for validating WordPress credentials, and it used two distinct methods to do this against a WordPress installation. Now, the two methods that it says that it used, one was HTTP wlogin, and the other was the WordPress XML RPC API. Now, that second method was particularly interesting to us because XML RPC was, of course, the name of the typo-squatted package we'd seen in NPM. So we also wondered who might be interested in using a tool like this, and we came to the conclusion that it was likely going to be offensive actors or maybe red teamers, pen testers, and so on. In other words, anybody that wants to validate a large dump of credentials. So further down the README page for this tool, we discovered these example usage instructions. And as you can see on the slide here, both of the examples suggest running the tool against a file named target.txt. And this file is supposed to contain the credentials that are to be validated. So further examination of this repo led us to a package.json file, which, for those of you that don't know, typically lists dependencies for a Node.js project. Of course, what do we see in this file? But one of the dependencies is the very same XML RPC typo-squatted package that MUT1244 had already used to distribute InfoStealer malware. So this, of course, explains at least one initial access method for the malware and the involvement of the targets.txt file. So piecing all of this together, we now have our full attack chain, which can be viewed on the slide here. So let's summarize what we know so far. We know that MUT1244 are attempting to compromise academics with InfoStealer malware via a phishing campaign. We also know that they're attempting to compromise Node.js developers via this same malware, which is delivered by first executing some obfuscated script that's hidden in an NPM package. And finally, we know that they are targeting offensive actors via a Trojanized credential checker tool that we saw on the previous slides. So this slide shows you an overview of how the Trojanized credential checker actually works. So we can see that the first stage is that the offensive actor or pet tester and so on first acquires some stolen credentials that they want to validate. They'll then execute the YOP tool against these credentials, which performs the login against a WordPress installation using one of the two methods we saw previously. At this point, the InfoStealer malware is executed in the XML RPC dependency, and the credentials are then exfiltrated to MUT1244's Dropbox account. And that's it. Thank you, everyone, for coming to our talk.
No, come on, Matt. There's more to it. So, of course, that was just the beginning. Otherwise, it would make a 10 minutes DevCon talk not very funny. So the next thing we want to do is to pivot. What do we mean by that? We want to find more payloads from this threat actor. We want to find more indicators of compromise. And basically, we want to map out a little bit more what they are doing. So one very naive thing that we can do is look up the payloads on GitHub. It might work. You can see here that we have a few of the payloads from the same threat actor on different GitHub usernames, but it's not great because many of the repos are taken down or they are not even indexed in GitHub code search. So ideally, what I'd like as a researcher, right, is to get the full GitHub on my laptop. There's no way to do that. But there's an open source project that gets very close to it, which is called the GitHub Archive. And that's an open source data set that continuously scrapes the GitHub Events API. And it puts that available into a set of JSON files, compressed, one for every hour of the day. And 1 year of data is basically 1 terabyte of compressed JSON, so it's not that huge. And this contains all of the public commit, star, fork, push events that you will see on GitHub. So for anyone doing OSINT or threat research, it's obviously a very interesting piece of data. Two ways that we can consume that. First one is using Google BigQuery. It's a service by Google Cloud where you can query public data sets like this one. It works very well. It has all of the metadata. You have to be very careful, though, because if you do select star on a very wide range, you're going to pay a lot of money because you pay by terabyte of data scanned. So this query here is going to cost you like $130. You need to be careful. Now, if you don't need the full metadata, you can also use this, this playground from the ClickHouse demo. So ClickHouse is a colon store database that is very efficient, and they want to show you that it's very efficient, so they have a public playground where you can query public data sets for free without any kind of authentication. And for instance, this query runs on like 9.6 billion rows and takes 2 seconds to run, or 3 seconds to run, which is very, very efficient. The nice thing about this one is that you can also use it through the API. So you can see there's no authentication. You just pass the query and you get back the results. So this is great for any kind of research that people want to do. Now, why did we even want the GitHub Archive dataset in our case? Well, we had one GitHub user named Paul Muir 1977, which you might remember. And so many of their repos had been taken down. And so we wanted to see what they had interacted with in the past. So the way we do it is we ask the GitHub Archive dataset, hey, can you show us anything that this user had shared, had forked or starred in the past year, 2 years? And we get a few things. Now, these repos had been taken down, but we can still see them because now they are on the GitHub Archive dataset, right? And then we link them to the user that owns them, and we iterate one more time. And if you keep doing that, in our case, you end up with something that looks like this, galaxies of users or communities, if you are doing graph theory. And these are basically So the edges, the vertices are users and repositories, and the edges are when they interact with each other. So if they start something, if they fork something. And what you can see here is basically a set of inauthentic GitHub users that interact only with each other in order to promote inauthentic, fake, malicious content on GitHub. Now, Matt, can you show us a little bit what they are promoting? Because that's also the point of the operation, right?
Yeah, sure. So those of you with good eyesight might have noticed some of the projects that Christoph highlighted had CVE numbers in the name. So let's have a little bit more of a deep dive into that. So as we've heard so far, MUT 1244 placed a particular emphasis on attacking security researchers and academics working in the tech industry. So one way that this was achieved was through the use of fake proof of concepts for various vulnerabilities. Now let's take a look at what some of the GitHub repositories and profiles looked like that backed these vulnerabilities. So here's an example of a suspicious profile on this slide. And what we can see on screen here is a likely AI-generated image that's been used as the profile image. And we can see a relatively blank profile. There's only one repository that this user has actually contributed to. Now, most of the profiles that we encountered during this research followed this same general pattern. Now, to add legitimacy to the proof of concepts themselves, they often included a detailed README. So this generally included technical details about the vulnerability itself, often linking out to technical papers or the original vulnerability disclosure. Now, most of the repositories also included some detailed usage instructions, and you can see an example of this on the screen here. So typically, the loader payload that we've mentioned previously would be executed as part of these instructions. And as you can see, I've highlighted this malicious configure script that contains the payload itself. So in this example, of course, when the user runs this configure script, the loader would run and eventually deliver the Codeberg info stealer. So here's yet another example, this time focusing on an RCE vulnerability in Kubernetes. So again, we can see a believable README providing a useful technical overview of the vulnerability itself. Now, in this particular example, MUT 1244 has claimed that they've incorporated a previously unused attack vector into this exploit. Now, this again is the kind of information that you would expect to see in a POC repository, and of course, it generates interest in the POC itself with the supposedly unused attack vector. Now, often responders are under pressure to understand these types of vulnerabilities, and they may run something like this after a lapse of concentration. But we actually think that this particular vulnerability, or exploit, I should say, was the likely target of it was actually offensive actors because they've placed so much emphasis in this unused attack vector. Now, those of you working in vulnerability management have probably used things like Feedly to try and stay on top of emerging vulnerabilities. So we wondered if these fake POCs were actually being aggregated in such services, so we decided to take a look at this. Now, this is an example of a Feedly report for another Kubernetes vulnerability. Scrolling down the page, we can see that a MUT 1244 malicious POC is being used as an example exploit here. So this page would typically appear in the Feedly vulnerability dashboard, which of course adds credibility to the exploit and might also lure researchers to it. So we can see that Feedly links out to our malicious POC on GitHub to a repo containing the same initial access payload that we've described previously. Okay, so this is an attack graph for the Trojanized repositories. We can see how each cluster of repositories delivers a first stage payload that's hosted either in NPM or in Codeberg. So this also shows the different exfiltration methods for each cluster of Trojanized repositories. So you can see that some will exfiltrate to file.io and others will go directly to Dropbox. Now, newsreaders like Feedly are of course one way to get the POCs in front of more potential victims. But MUT 1244 wasn't content with that method alone. So we found some additional evidence of them trying to promote the POCs via their own website. Now, this site contained a list of articles about vulnerabilities, the content of which was basically stolen from other sources across the internet. Now, this site itself was still up at the time of writing the talk, but as we can see here, the last posts were in January 2025. Now, each of the articles contain technical details about the vulnerability itself and some instructions on how to run the exploit. So it's kind of similar to what we were seeing in the READMEs shown previously. So some articles here contain an embedded script, which is supposed to be the POC code itself. However, as we can see on screen, if you scroll further down, you'll typically encounter these usage instructions, which try and get the user to clone this dodgy Codeberg repo. Of course, this repo contains the same MUT1244 malware that we've spoken about previously. Now, to see how this website was actually promoted in the first place, we used a backlink checker and we noticed several references from SEO sites. So it seems like MUT1244 has actually purchased SEO services to try and push the site higher in search rankings. But of course, that's not all. We also discovered this X account with the CVE POC name and some AI-generated images. Now, at the time of discovery, the account didn't actually have many followers, but it was likely used to promote the POCs. So here's an example of a post from the account that links directly to the CVE POC website that we saw a couple of slides ago. Now, this post is promoting a POC for a vulnerability in Apache Tomcat, and of course, the POC contains the same initial access payload that MUT1244 is trying hard to distribute. Now, all of this supposedly organic content lends some credibility to the POCs themselves, and it also helps to establish MUT1244 as a genuine researcher. Okay, so we know that MUT1244 tries to target academics, offensive actors, and vulnerability researchers, but are there any other demographics that might happen to fall for this? Well, it actually appears that individuals interested in cryptocurrency and blockchain technologies are also on the hit list. So we found this strange crypto forex lead site containing stolen or generated articles about various crypto and blockchain topics. Now, amongst these articles were some that focused on vulnerabilities, kind of similar to the ones that we'd seen on the CVE POC site. Now, I'm not entirely sure if there's any crossover between cryptocurrency geeks and vulnerability researchers, but MUT1244 seemed to think so. So, as you can imagine, by this point, we had a number of malicious usernames to pivot on, along with target demographics for MUT1244. We also knew that they were interested in cryptocurrency and blockchain topics, and one username that kept reappearing in relation to this was ethgeeks. So we did some more digging and we discovered this GitHub profile with the ethgeeks name. Now, one of the popular repositories that this user had contributed to was for a tool named Token Recovery, which I've highlighted on screen here. So we found yet another website that is actually dedicated to this project, which gave us some insight into its purpose. Now, supposedly, Token Recovery is a tool for retrieving ERC20 tokens that have been mistakenly sent to contracts. And of course, this is actually impossible without the private key of the recipient. Now, on this website's homepage, as you can see on the slide, there were links to Windows and Linux binaries for the tool. Now, unfortunately, at the time we were doing this investigation, these links were unavailable, so we weren't actually able to gather the payloads. But I would say that there's a fairly high chance that it contained the very same InfoStealer malware that we've seen several times. So here's the About page of the Token Recovery website. We can see some more information about the project and the noble goals underpinning it. Again, this attempts to add some sort of legitimacy to the project, but not only that, it actually connects it with the ethgeeks GitHub profile that we'd seen previously. So as usual, being security researchers, we asked how exactly was this being promoted in the first place? Well, searching for mentions of token recovery across the internet led us to this Medium blog published in August 2023. Now, the author of this blog is Paulina Buller, which of course sounds very similar to Paul Muir, the pseudonym that we've seen several times already. Well, it turns out that this is indeed Paul Muir, as can be seen by the Medium username in the article's URL. And this, of course, is further confirmation of MUT1244's connection to this project, and it demonstrates their keen interest in cryptocurrency, blockchain, or Web3 projects. So we also found some additional evidence of this tool being promoted on the internet. what you can see on the slide here is a profile for a Quora user with the name Dendrum. Now, we can see this user has the token recovery link in their bio, and they've helpfully answered several questions about cryptocurrency topics. Now, if you look at the bottom of the screen here, you see that they've also posted a question where they're actually complaining about the amount of scammers on Quora and the lack of Quora moderation. So further research into this led us to this forum post on bits.media. Now, for those of you that don't know, bits.media is a Russian language forum for crypto and blockchain discussions. So the post itself was made in 2022, and once we translated it, we can see that it's clearly promoting the token recovery tool. So we can determine from this that MUT 1244 first targeted crypto and blockchain communities before moving on to academics, pen testers, and red teamers. Now, evidently, they've been extremely busy promoting malware across a diverse range of targets, but just when we thought we'd seen it all, the rabbit hole deepened even further.
So if you remember, this was in December. A few weeks after that, we took some time off. I went skiing into the French Alps, and we just kind of paused the investigation. When we got back, we saw that the threat actor has tweeted some things, and he was basically complaining about file.io not working anymore. If you remember, that's the file sharing service that they were using for exfiltration. And that corresponds with when file.io was acquired by a company named Muir, which you might know if you were born in the 90s. And so at the time, the file.io thing stopped working, and that's the threat actor complaining about it. At this time, we kind of switched tactics a little bit for the exfiltration, but also we found this post from a French pen tester called Valentin Lobstein, where he basically says, hey, I'm a pen tester, I needed to exploit a vulnerability, so I found a POC. For this one, I ran it, and I figured out that I was infected. So this is, that story, but also he found that the threat actor has tested his own malware on their own machine and exfiltrated their own data on a publicly available place. Which for us is great, right? We have bash history, SSH keys, passwords, a lot of things like that. Now, this is an example on the top of the threat actor trying to authenticate to a few of their C2s. The one below is when they are trying to figure out, if you remember that phishing campaign, which victims haven't gotten the phishing email yet. They are humans, though, so they make some typos. As you can see on the top, they are using some typos when they do apt install as well. And the bottom is when they are trying to authenticate to an RDP machine with stolen credentials. So this is great for us, right? This is super interesting. I think a bit more than 2,000 lines of bash commands. And a few more things that we can get from that is actually the GitHub usernames that they use. So what you can see here is the Git commands that they use to set the Git remotes and URLs before pushing the malicious POCs, which gives us some more insights into what malicious user profiles they are using on GitHub. And one of them was interesting. It's called abullet with a 0, and Matt is going to tell more about that.
Yeah, so we were able to track down yet another GitHub profile that was operated under this name using the GitHub archive dataset that Christoph mentioned at the start of the talk. So the user didn't actually have any public repos listed, but we noticed that they'd created and commented on several issues related to AI image generation projects. Now we can see 2 examples of these issues opened by the abullet user on this slide, and these were opened under the project Stable Diffusion Web UI Forge. So of course, this tells us that they're interested in AI image generation, which, as we expected, was the source probably for the profile pictures that we found throughout. Now, despite this, we're unsure whether they're interested in this simply from a hobbyist perspective, or whether they intend to actually target this community at some point in the future. Finally, we also discovered this screenshot of Total Commander from a reply to one of the GitHub issues. You can see on screen here that it's a Russian language version of Total Commander, which fits with the language used in the forum posts we saw earlier. So I'll now hand you back to Christoph to discuss detection methodology for this.
Yeah, so first I want to show a few reports that happened in 2025 of people finding malicious stuff in GitHub. There's one from Reversing Labs, one from Kaspersky, and these are slightly different. They are not specifically proof of concepts like we have today. They are more like tools that look legitimate, but that are actually backdoored. And then we have a few research papers that I like that talk about how to detect malicious things on GitHub. This first one is from the Rochester Institute of Technology, and it shows how to use commit metadata to find malicious contributions in open source projects. So it's a great paper. If you want to read it, it's a great one. This one from the University of California, Riverside. They do a lot of things, but one of them that's interesting is they classify different sets of users into malicious and benign, and they look at what are their fields that are set on their profiles. So that's really interesting for us because it allows us to characterize what might look like a malicious or a benign users. As a very simple example, you can see that 95% of benign users set their full name versus 28% of malicious users. And finally, this one is from the University of Leiden in the Netherlands, and they specifically look at POCs, so GitHub repositories called POC-CV-something, and they look at the content of the repositories. They found that almost 2% of these POCs were malicious or backdoored. When we did this investigation, we had a lot of heuristics because we found a lot of malicious repos and users. So we wanted to try to encode that into a tool that anyone can use to scan a repository or a user on GitHub. And that's an open source tool that we are releasing just today. And so the way it works is that it analyzes the metadata of the GitHub users and the GitHub repositories. It doesn't look at the data inside of the repo, but it looks at the forks, the different characteristics of a user, and anything that might make it stand out. So for a quick demo, that's the one. So, that's an open source tool that you can get from GitHub right away. And it has a bunch of heuristics for repositories, for users. And if you click on them, you can directly see the code. Now, on the demo, you can see we opened a few malicious GitHub user profiles and malicious GitHub repositories that were not down at the time we recorded that video. I'm just going to copy-paste the username of that one into a terminal. And what you will see, I'm going to run ghbuster with the username, and that's going to trigger a few heuristics. I'm not going to go through them all, but basically it's telling you this user has forks of repositories that have been taken down, which is generally a sign that the fork is gone because it was malicious. The parent of the fork is gone because it was malicious, but the fork remains. You have things like the user only has commits from unlinked emails. So if you go through all of the commits from all of the users across all of the repos, you only see commits with metadata where the email doesn't link to the user's GitHub email address, which generally is a sign that you have a threat actor that uses a bunch of GitHub profiles, and they don't, change their Git commit metadata every time. And you have some other simpler ones like low community activity or some profiles fields that are not set while they are generally there. If we go to the fork, we can see here that the fork is online, but the parent repo is down. So that's what this is detecting. And if we go to the list of repositories, we see that this user only has forks. Now moving on to the next one. This is a malicious repository. We can just copy-paste the URL as well. We do ghbuster, the URL of that repo. And here it's going to find, same for the repo. There are no, all of the commits are from suspicious unlinked emails, meaning that, as you can see here, I cannot click on the Git username because the Git commit metadata has an email that isn't linked to the user. And finally, if we try that on another user, on another repo, that one is going to take a bit more time, but it's going to also analyze anyone who starts the repository and run the heuristics on them. So as you can see here, it's going to say, for every person who starts the repository, I'm going to run the heuristics, and the goal is to figure out if this repository has been fakely promoted. So what you can see here is two things that triggered. One is that the repository was started only by users that seem suspicious. And secondly is that it has stargazers who all joined on the same day. So if we go here to /stargazers, we see that many of the people who start the repo joined GitHub on the same day, on April 26th. So again, they didn't start it, they joined GitHub on the same day, which is definitely suspicious. So that's the tool. Feel free to use it. It's open source, and if you have some feedback or some recommendations, we'd be happy to discuss that. Now, wrapping up a little bit, this is the campaign that we showed today. Again, a bunch of Trojanized attack tools and POCs that are targeted at pen testers, offensive actors, security researchers, that end up delivering the same payload that steals some data, including some credentials, along with a phishing campaign that acts as another initial access vector. And as a key learnings, at least for me, on this investigation is that proof of concepts are great targets. Why? Because when you're a pen tester, you need to keep up with all of the POCs, test them, so there is a high chance that someone will run it, right? Also, as a pen tester, it's likely that you have access to some credentials, to some highly privileged systems. But running untrusted code is not a problem that's only for proof of concepts, right? Anytime we do pip install, npm install, that's the same issue. Finally, as I think Matt has spoken in great length, how to make something look legitimate is a big part of the threat actor's operation, and that's a good opportunity to find them and try to, pull the thread and see what we can find from there. Finally, there are a lot of open data sets. We showed today the GitHub archive and 2 different ways of using it, but there are many more on like Hugging Face, for instance. They are great for OSINT, threat research, so go ahead and use that. And that's all for us today, so thank you for coming. I don't think you have any